Hello, everyone. I'm Joe Ross, partner with Televate. I'm here with my friend Emil Ulbrich with Primeline.
Good to see you again.
Good to see you too. Emil, today I want to talk about low Earth orbit satellite services direct to cell. So I think that they're a game changer for public safety, for push to talk or CAD, situational awareness in remote areas where there's no terrestrial service, and then perhaps even a backup for cell networks. What are your thoughts on this tool for public safety personnel in the field?
Um, I guess I'll just cut right to the chase. I do think it is a game changer, and the reason why is that if you take the land mobile radio component out of it, unlike a traditional satellite phone like an Iridium phone or Globalstar phone that required specialized equipment and cost a lot of money, and you got to pay for a satellite service. The interesting thing about the direct-to-cell technology now is that the phone and devices in the officers' pockets that they carry already are capable of this. So that fundamentally changes the economics and logistics. You don't have to deploy a fleet of specialized satellite phones and hope someone grabbed
Mhm.
one before heading out into the field. Every
Absolutely.
officer's got that device in their pocket. So that in and of itself is a huge game changer.
Excellent. Agreed. Totally. So what's the status of the service? What's the status of these networks in the United States?
Well, so there's a lot of confusion. If I can just spend a second talking about, there's actually three different services available on the carriers right now for direct to cell technology, and they all operate a little bit differently. So um, you talked about LEOs or low Earth orbiting satellites. There's
Mhm.
also GEOs or geosynchronous satellites.
Right.
And so that service is offered by a company called Skylo on Verizon's network. The GEOs sit way up. So you only need three satellites to cover the entire planet, right? And they're 22,000 miles in space, way, actually right over my shoulder here, right? And um, there's certain phones and only Verizon carries it, and that's good for like SOS type messages, location updates, hiker
Right.
lost. You'll see the little beacons that hikers have or skiers, backcountry people that hit it. That's what it uses. The new S25 phones support that, and a few other. The Pixel, I think, supports it. But they're very limited in what they can use. A few text messages, things like that. The low Earth orbiting satellite offered by there's one by SpaceX on T-Mobile and the other one by AST that both Verizon is partnered with, but primarily FirstNet and AT&T. Those are much lower, right? And so those operate about anywhere from 200 to 300 miles in space. And you compare that to like a rural cell site, which is like 10 miles, right? So you're talking about something that's really far away, but they're very usable. The SpaceX system that T-Mobile is using is actually commercially available now. Almost a year ago in July, it went commercial. The AST Space Mobile is under testing right now and hasn't launched commercial. I think in the second half of 26 here, they're going to start doing limited rollouts of that. A lot of that has to do with getting satellites up in the air and things of that nature. But very similar that you can use, in fact, this phone right here out of my own personal phone, you can't see it right there. I use that for testing, and I didn't have to do any modification to it. So again, a lot of the modern phones that officers have and that they're utilizing personally or within their department are capable of this. So really cool technology. But um, AST, they haven't gotten authorization. One of the interesting things, they're an STA, Special Transmit Authority from the FCC. So they have to get more satellites up to get that continuous coverage, but that'll happen. That's just, a launch capability. And as they launch more satellites up, they'll get better coverage.
So are there any restrictions on the T-Mobile network on what people can do with their service, the T-Satellite service?
Yeah. And one thing on the SpaceX T-Mobile service is that there's a difference between the direct to cell technology and then the SpaceX broadband. So the SpaceX
Mhm.
broadband stuff that you can buy at Best Buy or Costco, the little square dish that you get, that's for broadband service. And you can get that on vehicular systems too, and RVs and whatnot. The direct to cell is a totally different satellites, totally different technology and whatnot. And there is a big difference. So the broadband service is exactly that. It's a broadband internet service. So the direct to cell is very limited. They have a limited amount of bandwidth in the US. So
Mhm.
they're using a 5 megahertz LTE channel. So they're using 4G technology. Um, it works when you don't have terrestrial coverage. So when you go out of cell phone coverage, like for me, I live in the Rocky Mountains, not on the moon. And so when I drive out of coverage, it will eventually switch over to satellite coverage. But there's a gap there of a few seconds if I'm driving or if I'm hiking or something like that. Once I lose coverage, it'll go to satellite. So it's designed as supplemental coverage for that. And the applications that you can use are limited. You can do texting, you can do WhatsApp voice and video. No voice over LTE yet. And then there's some apps like All Trails, some Gemini apps and things like that that you can do on there also.
So what would that mean for public safety's use of in-car routers for CAD and the like?
So on the T-Mobile T satellite direct to cell, it doesn't support in-car routers or MDTs or any embedded modem. So that's off the shelf. So if you wanted to do that, you'd be better off getting the broadband solution and mounting it on your vehicle, right? The square antenna. So that is a solution. It's expensive, but if you live in an area out in the middle of the desert or you don't have coverage, that's your solution. But as far as a smartphone solution, you're limited to those applications right now. The AST, their intent is to offer higher broadband speeds. So right now, it hasn't been third-party tested by someone like me, but if you look at their demos, they're doing about 10 to 15 megabits per user within a cell. And they can do, their peak is around 120 megabits according to their marketing material. You got to remember though, that's a peak speed for a cell that gets divided by all the
Not
users in
shared.
that. Yeah, it's not, it's
Right.
shared. So if that the cell size is pretty big on AST, it's about 26 square miles or 20, it's 13-mile radius, so more square mileage than that. So about 26 miles across. So big cell size. You get a lot of users in there, you're dividing that throughput. So you have to manage your use cases and data throughputs accordingly.
When do you think T-Mobile will lift their restrictions? Are they going to increase their capacity?
I think on their current satellite, and I can't speak for T-Mobile, but just as, from my analyst hat on and testing their network out, I think the applications that they have right now, they're going to stick with. And then next year, they're going to be launching their V2 satellites for the direct to cell. And the intent is that that's going to have a 100x increase in capacity. They also bought a bunch of additional bandwidth from other companies, and that's going to increase their performance. So they realize they have competition with AST, and so that performance will change. So with that performance comes capabilities, and those capabilities might include, MDTs and routers and things of that nature. Remains to be seen, but my guess is that they'll probably start to offer that.
So when do you think both of these companies might have a service that's more fully supporting all the public safety broadband data needs?
That on the T-Mobile side, on the SpaceX side, if they start launching next year, I would say by early 2028, that service would probably be available. AST, right now, I believe they have 6 satellites up. They need about 45 to 50 to provide contiguous coverage over the continental United States. So if they can do, 20 a month, they can meet their goal by the end of this year. That's a really aggressive goal. But if they can do that, then I would say by the end of this calendar year, they'll start to have contiguous coverage. Right now, it's not contiguous, but as they add more satellites, that'll get better. And then they'll have their new satellite array is quite large. In fact, it's the largest, I think, satellite available. So that should be available probably the beginning of 27.
Cool. So let's talk about coverage for a second. One of the things that I see on the T-Mobile marketing literature is that they recommend its use with a clear view of the sky, like the Starlink broadband service, and not under a tree canopy or in valleys. Is that just a temporary restriction, or is there something that needs to be upgraded to be able to get service to where you can use it outdoors everywhere?
Boy, there's a lot of nuances to that. So there are gaps, no doubt about it, right? And
Mhm.
part of that has to do with regulatory policy. They cannot cause interference to the terrestrial network, so they need to provide a buffer zone there currently. Now, if they own the spectrum and they don't have anyone to worry about with interference, then that becomes less of an issue. So the new spectrum that they bought will hopefully eliminate that problem where they could have more contiguous coverage. So
Mhm.
that's the first problem. The second problem is that the technology that they're using is 4G, and it has some limitations with handovers to the terrestrial network. Once they go to 5G and they get this new implementation in what they call NTN release 17, and it'll be a future release going forward, that'll allow a more contiguous handover between the terrestrial network and the non-terrestrial network. So the satellite to the non-satellite network. And that's really what you want, right? As a first responder, just have a seamless coverage. That's probably not going to happen until that 2028 timeframe.
Mhm.
But with that, I think the AST model is a little bit different than the SpaceX model. The AST model is to provide coverage holes and fill those gaps and coverage gaps. So even within the terrestrial network, provide coverage. Whereas the SpaceX model currently in the US is to supplement the coverage once you get outside of it. So you kind of have to get outside the coverage area,
Mhm.
then you go to satellite. Whereas maybe you have a coverage hole within between two cities and you're covering this rural area or in a canyon. The thought is that you'll get that. The other thing too, I will say, is that density of satellites. As they launch more satellites, you probably see in the news, they're going to launch more and more satellites. They're going to go from 650, maybe up to 15,000 satellites on SpaceX. That's going to get you more beams, more coverage, better performance. Same with AST. As they go from 6 satellites up to 50 and maybe up to 100 plus, they're going to get much better coverage as time goes on.
Mhm. So by that time, 2028 is going to be when you don't need a clear view of the sky. You can be under a tree canopy. You could be in a valley, behind a mountain, and it should work.
Yeah, because you'll have more satellites passing over, more beams. Now,
Right.
it won't be perfect everywhere, right? It depends how deep the canyon. But, just from my own personal testing, I've had my in-vehicle penetration works fine in my car on SpaceX, and I've had first wall penetration, with that limited, but it does work where
Mhm.
it's not supposed to. It's not perfect, but you can get a message out when you need to.
So it might work indoors a little bit.
A little bit. Yeah. And the AST will have a better performance just theoretically because of a bigger antenna. So that should uh, gain them a little bit better performance, especially in those difficult situations when you get in between a wall. And the thought is that if you get inside a wall, that you would have terrestrial coverage or something like that. But if you don't, at least you have something. And I think
Mhm.
that's the key, is that coverage is king, right? We talk about capacity and all that, but if you have no coverage, something is better than nothing, I think, in those instances, especially
Yeah,
wildfires.
sure. So you were talking about these buffer areas where, there's gonna be some delay. Is there plans to have continuity of service between the terrestrial and satellite networks?
Yeah, that seamless coverage is something, I work in the standards that, is trying to figure this out. And there's a lot of complexity. You're talking about, I mean, you have issues, we still have handover issues. I think everyone can attest, oh yeah, I drive over this hill and I drop a call. So we still have that in terrestrial networks. We haven't
Right.
quite figured it out. Now you're talking about a satellite whizzing over really, really fast, and it has to hand over to another satellite and then to, the terrestrial network and not drop the packets. That's a challenge, no doubt. There's a physics challenge there. It won't be perfect, but it will get better. Right now, it's a break and then make scenario. So you kind of break your connection that makes it, but it's relatively quick, a few seconds. That will get down to where it will become imperceptible. I think for telephony voice, it will be a challenge, but as you get those more satellites, Joe, the performance will get that much better. For push to talk, I actually think it's a much better application because it's not continuous voice. We're doing it with the satellites, right? Right now, with the guys going to Artemis, pushing a button, talking to them, they're responding back. So it works.
Right. Right. Short calls probably a lot better for that scenario. If you
Yep.
want to have a long phone conversation, maybe you're going to have some gaps.
Yep.
Is there, so do they have plans or there standards in place that will have that continuity of service?
Yeah, absolutely. So, the standards go through these different releases. And so most networks are on like a release 16 release. As you look ahead to like release 18 and 19, it absolutely addresses all of these type of issues that you're talking about. The
And
seamless
that's,
continuity, the handover, hand back. And that's, a few years out, but that hits that kind of 2028, 2029 timeframe.
mhm. Sounds like everything is converging to 2028.
Yeah.
Um, so, I talked about it being a backup for cell networks. So one of the things that, public safety likes public safety grade, only 4 minutes of outage a year, highly reliable networks. Is it something that, is this a solution, where you can have that backup from space and be able to provide service if the terrestrial network goes down in a major blackout, or if a hurricane comes through, or ice storms come through and knock out a bunch of towers?
So all these satellites that are up there, one of the things so the short answer is yes. I think that the technology is there. You look at Hurricane Helene and Milton, T-Mobile and SpaceX, they actually activated direct-to-cell in those disaster zones, and people were able to send out emergency text messages, and they did that on the fly. There was ad hoc activation. It wasn't always on, and so they did that for people that were trapped there. So that's something they could do dynamically because they had these software defined systems and they could adjust the satellite beams to provide coverage where they needed to. So absolutely both those networks, both AST and SpaceX will be able to do that for sure.
Will it be transparent? Will it be immediate, or will it take like 10, 15 minutes before they reconfigure the networks to provide that backup service?
That's really up for a carrier implementation. In theory, they could do it, per spot beam. So a new spot beam comes over, boom, you immediately transition it over. So that's something that could happen relatively quickly, right? And I think and I hate to bring up the word AI, but as you get it to more automated systems that can be triggered in emergency events to enable something like that. So if you know what the use case is, oh, hurricanes here, we need to implement this feature here, and there's people located here, boom, we can turn that on. I see that as absolutely valid use case and capability that we could do right now. It's whether or not, the carriers are going to do that, right?
Yeah, the carriers are going to have to send messages that this cell site or these cell sites are out, provide service to this area.
Right.
Otherwise, the satellite service provider won't know.
Right.
So when that happens, so, let's say that there is a scenario where there's a major outage from a hurricane or some other mass blackout. It sounds like there's going to be a lot of people that are going to be operating their cell phones on these satellite networks. Do the satellite providers have a lot of capacity available for millions of users in an urban area that lost service?
I mean, this is a challenging question. So, I mean, capacity is a real problem. I mean, we talked about coverage, right? That's our main discussion today has been about coverage. Today's direct-to-cell satellites, they are capacity constrained for sure, right? You're limited there on the amount of bandwidth, how wide your band is, your channel, how many satellites you have. So our terrestrial networks are designed to handle, millions of simultaneous broadband users sending all this data. If you have satellites up there and everyone's trying to do broadband data, fundamentally the math doesn't work out, right? So there does have to be some queuing mechanisms there. There does have to be some priority. I think when you start to get to public safety, depending on what network you're on, let's assume it's FirstNet, but it could be, Verizon or T-Mobile also. Those mission critical type applications like push to talk or, some type of fusion, tracking system or whatever it might be, those there's a lot of work that has to be done there, right?
Mhm.
There might have to be enhancements done at the application layer to handle or high latency type things when you have a lot of users on there. So capacity is an issue for sure. It will get better over time, but initially, I think you will see some pain points there if a lot of people are trying to access that.
So it'll be critical that public safety get priority over these networks to be able to communicate. So even if they had a network slice or, for T-Mobile or Verizon, you still need priority within the public safety priority and perhaps even more priority to make sure that that voice gets through.
I think the challenge is if you're, let's say, in that hurricane situation, you have people trying to get emergency calls out and emergency information. You have to be able to disseminate that traffic from the public safety one because that's important too, right? For the people there. So if you have limited bandwidth, yeah, being able to manage that, and I think that's where I don't think technology is our issue here. We can increase capacity as you get more satellites up there, as our regulator, the FCC, allocates more spectrum. We can
Mhm.
fix that. It will just take time, though, for sure.
Mhm. Right. So you talked about release 17, 18, 19. So there's a couple of devices that specifically mention that they support the non-terrestrial network or NTN in terms of radio providers that do both P25 and 5G. So now 5G. I think these are the first 5G capable radios, the Motorola Apex Next BN and the Harris XL 300. And both of them indicate that they support release 17. So is that good enough? What does public safety need to know about the release and what it does, and when will it be enough to support the kind of services that they're interested in?
Well, the one thing is, so Release 17, that was the first standardized 5G NTN framework. So what that does is it allows for proper native operation of NTN communication. So you get better mobility handling, you get optimized handovers. There's dedicated satellite bands. And so the devices and the chipsets in there all meet that requirement and they're software upgradable. So that's a key thing to get. If you want that capability, absolutely, that's something they're optimized for that. And then they'll be upgraded. The Release 18 stuff has not come out yet. So Release 17 is just out in devices now. So that's, I mean, pretty much cutting edge with regards to that aspect. All the current instantiations of direct to cell are LTE 4G based and they work on our existing things. They're just not optimized for the best performance for satellites. So they do work. It gets you basic functionality, but you'll have noticeable delays. There's no simultaneous handovers. Those type of things, aren't there, and they can't be right now. It doesn't mean though that it's unusable. It's just those are the limitations of it.
So they'll work, but there'll be some perhaps unpleasant gaps in service from time to time, as
Correct.
opposed to these newer releases are going to be more continuous for probably voice calls, right? So most push to talk calls probably won't be during these transitions, but there will be some. So if public safety wants to be sure that they're going to have continuous voice, then it's going to be more on these later releases that are coming probably over the next couple of years, also around the
Right.
2028 timeframe.
Yep. Absolutely.
Well, well, great, Emil. Thanks so much for your time today. This is really enlightening for me, and I think it's going to be enlightening for public safety that this is coming around. This is around the corner in terms of their purchasing, cycles. And really appreciate your time. And to everyone who watched, please like and subscribe on our YouTube channel and provide us with comments and any other feedback about other topics that you'd like to hear in the future. Maybe you'd like us to dig deeper into this particular subject with Emil. But thanks for your time. Have a good day. Bye.